Today we're going to discuss a problem called valid palindrome. Before we discuss what palindrome is, we need to know that it is case insensitive and we need to include only alphanumeric characters. For example, uppercase A and lowercase a are the same. We're going to treat them as the same character, and we need to exclude non-alphanumeric characters such as comma, space. Now let's discuss what palindrome is. What is palindrome? It is a word, a phrase, or sequence that reads the same backward as forward. For example, let's consider this word race car. Let's read forward. R-A-C-E-C-A-R, and backward R-A-C-E-C-A-R. So the forward and the backward are exactly the same, so it is palindrome. Now how are you going to approach the problem? Here we're going to discuss two ways of doing it. Let's discuss the easy one first. Let's take a look at this in example input string. The first character is uppercase, so we convert this into lowercase, and we move on to the next character, which is space, and that is non-alphanumeric. So we skip that character, then we move on to the next, and to the next, and next. Then here, comma is also non-alphanumeric, so we skip it, and which is followed by space, which is also non-alphanumeric, so we skip that one also. Eventually we get this string, and we reverse the string. Then we compare the forward and backward strings. In this case, they are exactly the same, so the given input string is palindrome, so we return true. Let's take a look at another example. Race a car. Here the forward and backward character different, so when we compare it, we'll get false. So this string is not palindrome, so we return false. Now let's code it up. First of all, I'm going to initialize an empty array to store the alphanumeric characters which we read forwards, that is from the start to end. Then I'm going to loop through each character in the given input string. For each character, I'm going to check whether it is alphanumeric. If it is alphanumeric, then I'm going to append to the string. I'm going to append the character to the array. Before I append it, I will convert it to lowercase, so I will store the lowercase of this character into this array. And finally, I want to compare this forward string and backward string. So in order to get the backward string, we'll just reverse this forward string. Then we return the result of this comparison. It means if the given input string is palindrome, this will become true. This comparison will give true, then we'll return true. If this false, then we return false. Now, what is the time and space complexity of this solution? For the time complexity, here we can see that we loop through the string, and each character we compare, we check whether it is alphanumeric or not, then we append to the array. So the time complexity will be O of n, since we loop through the string. N is the length of the string, so it is O of n. How about the space complexity? In this array, we store all the alphanumeric character. In worst case, it can be n number of characters, so the space complexity also is n. In the next approach, we're going to discuss how we're going to reduce this optimized space complexity. Now let's check our implementation is correct or not. Here we have syntax error because I forgot 1. So let's submit again. Here our solution is accepted. So this implementation is correct now. Let's take a look at the second approach. To discuss the second approach, let's consider this example input string. Instead of storing the lowercase alphanumeric characters in an array, we use two pointers, left pointer and right pointer. So if the characters at the two pointer are alphanumeric, we convert them to lowercase and we compare them. Then we move on to the next character. Since the next two characters are not alphanumeric, we skip them and move on to the next character. Here only one is alphanumeric, the right one is alphanumeric, so we move the left pointer to the next character, and both of them are alphanumeric and we compare them and they are the same. So we move the pointer until the left pointer is lower than the right pointer. Here the left pointer exceeds the right pointer, so we end the loop and we return true. Let's take a look at another example. Here the two character at the pointer are alphanumeric, but they are different, so we immediately return false. It means they are not palindrome. Now let's code it up. First of all, I'm going to convert the input string to lowercase so that I don't need to convert each character to lowercase. Then I'm going to initialize the left and right pointer to the start and end of the string respectively. Then I'm going to loop through the string until the left pointer is lower than or equal to the right pointer. If the left pointer exceeds the right pointer, then it will go off the loop. Inside the loop, I'm going to check both character alphanumeric. I'm going to check if both character alphanumeric. If both of them are alphanumeric, then I'm going to check if both the character equal. If they are not equal, it means the string is not palindrome. So I return false immediately as I don't need to check further. However, if both the characters are the same, if both characters equal, then I'm going to increment the left, then decrement the right pointer. If the left character is not alphanumeric, then I'm going to skip that character and increment the left pointer. I need to check if the left pointer is lower than or equal to the right pointer to avoid out of index error. The same way I'm going to check the right character. If the right character is not alphanumeric, then I'm going to skip that character and decrement the left pointer. If it loop until the left pointer is less or equal to the right pointer successfully, it means all the character on the left and right are equal, so it means the string is palindrome, so we can return true. So here, if we take a look at our implementation, the time complexity is the same as our previous implementation, that is of n. The reason is that we still loop through the string. However, the space complexity is only of 1. The reason is that we don't use any extra space to store the lowercase alphanumeric character as we did in the previous implementation. in our previous approach. Now let's check our implementation is correct or not.